You ever stop and think about plastic? I mean, really think about it. Some of it you can melt down and reshape, no problem. But other types, they just don't play that game. And you know what? It's not random at all. It's actually a tale of two very different kinds of plastic. So, let's get into it. Here's a perfect example. Think about a Lego brick. You could, if you wanted to, heat it up and it would turn into a gooey puddle, right? But what happens if you try that with the plastic on an electrical socket? It's a totally different story. It just chars, it burns, it basically falls apart. So, what's the deal here? Well, the answer to that little mystery is that pretty much every piece of plastic in the world belongs to one of two big families. And these families have completely different rules for how they behave. And here's the best way to think about it. Thermoplastics? They're like butter. You can melt butter down, let it cool and get hard again, and then you can melt it all over again. It's a physical change, it's reversible. Thermosets, though, they're like cake batter. Once you bake that batter into a cake, that's it. A chemical change happened. You can't unbake the cake. It's permanent. Okay, so let's get just a little bit nerdy. What's happening inside a thermoplastic? Well, it's made of these long, individual polymer chains that are all tangled up, kind of like a bowl of spaghetti. There are no real connections holding the strands together, so when you add heat, they get energized and just slide past each other. That's what we see as melting. And the most important thing to remember is that it's just a physical change. It can go back and forth. Now, thermosets are totally different. They also start out with long chains, but when you heat them up that first time, a chemical reaction kicks off, and those chains form these super strong, permanent bonds between each other. They create this rigid 3D network, like locking rungs onto a ladder. It is a one-way street. Once those bonds are locked in, that material is set for good. All right, let's meet our first family, the meltables. These are the butters of the plastic world, right? The ones that are designed to be melted down, reformed, and, this is a big one, recycled. And I promise you know these plastics. That Lego brick we talked about, that's made from a tough plastic called ABS. Your disposable coffee cup lid? Probably HIPS. You know that clear stuff, plexiglass? That's PMMA. And polycarbonate is so incredibly strong, they use it for eyeglass lenses and even bulletproof glass. We've even got bioplastics in this family, like PLA, which is huge in 3D printing. Okay, time for the other side of the family, the set-in stones. These are cake batters. These are the plastics you use when you need serious durability and heat resistance, when melting is the absolute last thing you want to happen. So where are these guys hiding? Well, that electrical socket on your wall is probably urea formaldehyde, and now you know exactly why it's used there. It won't melt. You know those super tough picnic plates that don't break? That's melamine. And those incredibly strong glues like epoxy or the polyester resins they use to make fiberglass boats, all thermosets. Okay, so we've met both families. Let's put them side by side and really nail down the key differences that set them apart. You see, this table pretty much tells the whole story. It really does all come down to that molecular structure. Because thermoplastics have those separate spaghetti-like chains, they can melt and be recycled. But because thermosets have that cross-linked rigid network, they get incredible strength and heat resistance. The flip side is they'll burn instead of melting, which makes them a real headache to try and recycle. And this isn't just a fun science fact. It has huge consequences for how we make things and what we do with them afterwards. So if you're gonna remember just one thing from all of this, let it be this. When you boil it all down, the entire difference between these two huge families of materials is simple. One melts, one burns. Think about it. From the phone in your pocket to the parts inside a jet engine, this one basic property, to melt or to burn, shapes everything around us. It's a decision that engineers make at a molecular level that affects our entire world. So the real question is, now that you know the difference, what do you think we'll build with them next?